sisters.
Sit down. Okay. 6-4, using inverse functions. Now, can someone tell me what an inverse function is? Okay, you say the opposite, right? Okay, that's a way of wording it, yes.
Yeah.
Mr. Rice doesn't like that terminology, but yes, that makes sense. Okay, so the inverse is something that is opposite of something else. When you have inverse functions, you have inverse relationships happening. Okay, so if my normal function has the inputs of 0, 1, 2, 3, 4, and the outputs of 6, 4, 2, 0, -2, when I have the inverse of that function, the x and y switch. Okay, so my inputs become 6, 4, 2, 0, -2, and my outputs become 0, 1, 2, 3, 4. Okay, the same thing happens with the domain and range. If I find the domain of my original function, and I find the range of my original function, when I have the inverse of that function, the domain and range flip spots. So your range from your original becomes your domain in your inverse, and your domain of the original becomes your range of the inverse. Okay? Domain is what axes are we looking at? X. How far does my graph travel on the x-axis? Range is how far does it travel on the y-axis. And when we write domain and range, we're going to start to write it with parenthetical stuff. So we're either going to use brackets or we're going to use parentheses. Okay? We're going to talk about a little bit what that looks like today. Okay. When I want to find an inverse relationship, it says find an equation for the inverse of this relation, y equals 3x minus 5. It's very simple. If you want to find the equation, that's the inverse of this.
-5, y equals -5x plus 3.
No.
Y equals -3x plus 5.
No. The first step is you interchange x and y.
X equals 3y minus 5.
3 divided by 1.
And then resolve for y. So I'm going to say x equals 3y minus 5. I'm going to add 5, so I get x plus 5 equals 3y, and then I'm going to
Divide.
and y equals x plus 5 over 3. So if they ask you to come up with an equation that's the inverse, that's what you're doing. Okay? You can handle that, that's not hard, right? Okay? So if they're asking for the inverse relation, that's what you're doing. You change x and y, you resolve for y. For any equation that you have, whether it's quadratic or cubic or anything, you change them out and resolve. Okay? Okay. Inverse functions. Okay? The function f and g are inverse of each other, provided that this happens. When you take the composition, when you take f of g of x and you plug that g of x in for the x's of f, right, and solve, you get an answer of x. If you then go and plug the function of f in for the function of g and you get an answer of x, you know that they are inverse functions of each other. Okay? This right here, that f to the -1, is the symbol for an inverse function. So, on our homework last night, we had functions that said f of x, or g of x, or h of x. That's the normal function. If you see f to the -1 like this, or g to the -1, or h to the -1, that's saying the inverse of that function. So you have the function of x, f of x, and then you have the inverse function of f of x. Okay? Okay,
Wait,
so,
I'm confused.
okay, what?
Go back. Please. So like, will it say f to the -1 x equals and then have an equation?
Yes. Or
So
they
that
will
means
tell
you
you
just-
to find f to the -1 of x.
And then give you an equation?
And they'll give you the original equation. You have to have one or the other to find the, yes.
So if it just has f of x, you're doing the opposite of that.
And it says find the inverse, then you're, yes. And if you
Okay.
want to find the original equation off of the inverse, you still exchange x and y and work it backwards.
Okay.
Okay? And then you'll get stuff like this too, Maddie, where it gives you both. And it wants us to prove that they are inverse functions of each other.
So you just pick one and do it?
No, you have to do two things in this one.
Well, you gotta flip it.
No. Stop getting ahead of yourself. If they give you a function and they say this is the inverse function, the way I check it is I plug this function into the x's of this function, and if I get x as my answer, yes. But then I have to take it one step further and plug this one into this one, and if I get x as my answer, then yes, I've proven that they're inverses of each other. So I am going to do this. And I'm going to say f of the inverse of x. Okay? Like that. No, you borrowed mine, but it might be yours.
This one's mine.
So from here, I'm going to plug in the green function anywhere that there is an x in the red function, yes? Okay, compositions, just like we did yesterday, except for this time, it's the inverse and not like another function like g of x. Okay, so I'm gonna say 3 times, and then this whole function is 1/3 x plus 5/3 minus 5. Now, let's distribute. What's 3 times 1/3 x?
3.
No. 1 what?
4/3.
X. 1 x. 3 times a third is 3/3, people. 3 times 1 is 3/3.
Oh, Charlie, son.
So you get x. What's 3 times 5/3? 15/3. Thank you. And then minus 5. So this gives you an answer of x. Stop. You're annoying me. Now you have to do this. Now you have to do this.
Why do you have to put that in parentheses also?
Because it might work one way and it might not work the other way, and if it doesn't work the other way, then it's not an inverse function. It's gotta work both.
So, shouldn't it say something else, cause it says verify that they are? So do you just put like they are not?
Yeah.
Okay.
So then from here, I'm gonna say 1/3 times, and this is where I put 3x minus 5, and then I say plus 5/3. What's 1/3 times 3x? Good. What's 1/3 times -5? No, it's not. What is 1? And you end up getting, and if you don't show me both of those, listen, if you don't show me both of those, you don't have your problem right on your homework or on your test and your quiz.
You don't get full credit.
You don't get full credit. You have to show me both. Okay, then we get fun word problems. But as Cameron says, they give you way too much information you don't need. Okay, elastic bands can be used in exercising to provide a range of resistance. A band's resistance R in pounds can be modeled by R equals 3/8 L minus 5, where L is the total length of the stretch band in inches. Find the inverse of the model. How do I find the inverse of that model? Yes, change the R and the L's and then what?
Then solve.
Then solve for R.
Yeah, that.
L equals 3/8 R minus 5. So add 5. L plus 5 equals 3/8 R. How do you get rid of a fraction?
Multiply by the reciprocal.
Beautiful. Reciprocal it up. And what do you get when you do that? 8/3 times L is?
8/3 L.
And what is 8/3 times 5?
Big number.
5 times 8 is 40. And to take 40 and divide it by 3, you're going to have a decimal. Do it.
12.
Are you stupid?
13.3.
Yeah.
Oh.
So we're just going to say plus 13.3. Okay? Equals R. There's the equation. That's the inverse. Then it says use the inverse function. That would be this one. To find the length at which the band provides 19 pounds of resistance. So what am I going to do?
Plug in 19.
To where? For
R.
R. So then I have 8/3 L plus 13.3 equals 19. Subtract 13.3. What's 19 minus 13.3?
5.7.
And then I divide, or I multiply by 8/3, right? So take 5.7, multiply by 8/3, what do you get?
Wait, wouldn't it be 3/8?
Oh yeah, 3/8. What do you get?
Wait.
Hurry up, Anna. What do you get when you multiply 5.7 by 3/8?
What's 5.7?
Guys, I need you to focus, let's go.
2.1375.
2.1, I'll just put 2.1.
Yeah.
And that is in inches. Okay, not so bad. Now let's talk about these. So, graphs are not going away in this classroom. You're going to do them every chapter. Get over it. Okay, you have done both of these graphs before. You're just not thinking about this. Okay, let's focus on the blues in both of these pictures. What type of graph is this in blue? A parabola, which means what power? A square function. A square function. The parent function of a parabola is just x squared. I input a 1, I get a 1 out. I input a 2, I get a
2.
I'm sorry, 2 squared is, and I near it, okay? Okay. What type of function is this right here that makes this shape?
An M.
Are you insane? Legit. Insane. No, it's one of those things that go like that.
Yeah,
I don't know what it's called
the
though.
cubic function.
Cubic function.
So the parent function of a cubic function is x cubed. X cubed. Okay? When I plug a 1 in and cube it, I get a.
1,
When you plug a 2 in, you get a.
6.
No. 8. Thank you. I need you to actually turn your brains on today, please. Stop shouting things out. Okay. 2 cubed is 8. Okay? And so this is what happens, okay? Now, we're talking about inverse functions. Okay? When I want to figure out what the inverse of x squared is, what would I have to do? Flip the x and y. So let's say I do that. So it says, instead of y equals x squared, it's going to say x equals y squared. So what happens, how do I resolve for y? Take the square root. Yeah, but we're going to talk about what this is. Now, a square root cannot have what inside? Negatives. Okay? So this is where I run into a problem with square root functions. What is the domain of a square root function? Not a square root function. What is the domain of a quadratic function? Look at this. Look at the blue. What's the domain of that parent function?
Zilcha.
Is the X, so it's
The domain is
0.
no. Domain is x. So how far is it traveling on this x-axis? If these arrows continue and it continues,
Infinite.
yes, infinite.
Oh.
So the domain of that is negative infinity to positive infinity. Here's my problem. When I go to a square root function, I can't plug in what numbers out of there? Negative, right? So my domain becomes restricted when I have a square root function. So the inverse of a quadratic function can't happen. Why can it also not happen? What do you notice about this red picture? What could I do to tell if it's an actual function?
Because it's.
This comes back to like literally basic.
Wait, repeat the question.
I want to know why, looking at that picture, I can figure out that the red parabola is not a function.
Because it's on the x-axis instead of the y-axis.
Because of what? The vertical line test. If I take a vertical line through here, it
Get it,
crosses
boys.
twice. You didn't say vertical.
I know, but I said a line where two straight lines and.
So vertical line test. So that's not a function. Okay? So it's not a function. Now, over here, if I take the inverse of the cubic function, right? If you take an inverse of that, you do it this way. You say, y equals, or y cubed equals x, right? And you're taking the cube root, and that's how we get that function. Y equals the cube of x. Now, can you have negatives in a cube root? Yes. Yes. Any power that is odd, you can have negatives in. Any power that's even, you cannot. I've said that 1,000 times. Now, does that mean, is the inverse of x cubed a function? Anna's right. Why is it? Yes, Anna.
These rules are arbitrary.
Why is, guys, shut up. Why do I know that the cube root of x is a function? Why do I know that that inverse of x cubed is a function?
What's the cube?
Because a 3
What did you
is a-
use to figure out that the quadratic, the inverse was not a function? Listen, what did we just use? Vertical line test. If I use the vertical line test on that, is it a function?
Yeah.
Yes, that's all you need to know. If I use the vertical line test and it only hits it once, it's a function. If it hits it twice, it's not a function. That's how we classify it. It's that simple. Okay? What is the domain of this original cubic function? Of the one in blue, what's the domain of this?
And negative, not negative, infinity to
Okay, now, remember over here, because this one's not a function, our domain gets messed up and we haven't discussed what that looks like yet. Over here, if the inverse is a function, what do you think the domain is?
a function.
Well, what is the domain of this red one?
The opposite of it?
Mm-mm.
The same.
Well, in this case it is because the domain of the red corresponds to the range of the blue. What's the range of my blue?
The range of your blue.
Which means how high and how low is it going on the blue?
Info.
Negative infinity to positive infinity.
When you have a cubic function, when you have a cubic function or the cube root function, you will always have a domain and always have a range that is negative infinity to positive infinity. You should
For
never
every single
miss
one?
that on a test.
For every single one.
Cubic functions do not end,
There's a Q in there?
okay? That is one that you should not miss on a test. People do. Do not be that person. Okay? On a cubic function and on the cube root function, the domain and ranges are always negative infinity to positive infinity. Yes. Okay. I think this is where we're stopping. I can't remember. It might be one more after this.
Oh boy.
Okay, listen. F of x. They want us to find the inverse of the function of x squared. Here's the deal though. Do you see where it says comma x is greater than or equal to 0? That means they're putting a parameter on our graph. An x squared graph means what type of graph do I have? A parabola. But if it cannot cross over 0 into the negative x's, that means I'm not graphing the whole parabola. Does that make sense? Okay, so let's talk about graphing this first, and then we'll talk about how we come up with the function, because it's a little bit easier to see it and do it at the same time. Okay, let's do this. If I input a 1 to a square root function, what do I get out? A 1. If I input a 2, what do I get out?
On.
Okay, and normally, and my vertex is 0, 0, right? And normally, I would mirror it over here, correct? But right now, I'm not allowed to graph this side because it says x is greater than or equal to 0. So I can only graph numbers that are greater than or equal to 0. So my graph is looking like this. Okay? Now I want to create the inverse of that. How do I create an inverse of a function? You switch the x and y, you resolve. So I say x equals y squared, we just did this one, we took the square root, and you get y equals the square root of x. Now, if I take the square root of 1, what do you get? If I take the square root of 4, what do you get? Look at what this is happening.
That's cute.
That's my inverse, actually.
Taking a quiz.
That's different.
It's kind of funny, but you can make flowers using inverse of sine, cosine, and tangent. Yeah,
Really?
you're right.
I told you, see, just put me in algebra, I don't gotta take you.
How did I know he's back there?
Okay, so I get that, okay? I graph it and I get it, because it said graph it and find it. So I did both portions. Now, I'm gonna take it a step further. I want you to tell me the domains of these. Okay, let's start with the black graph, okay? The domain of that is what? What is my domain of this black graph? We've gotta get used to doing domains, that's why I'm throwing it in there. No, it is not.
Zero.
It's what? Anna?
Zero.
0 to what?
Positive.
To infinity, okay? But because this says greater than or equal to, or if it says less than or equal to, I use a bracket.
Oh dear.
And then I say to infinity with a parenthesis.
To infinity,
What is the range of this function?
Zero to positive infinity.
Yes, 0 to positive infinity. It happens to be the same on this one. That won't always work. 0 to positive infinity range. Okay? Now, tell me, what is the domain of my red function?
0 to positive infinity.
Okay, because technically, it's the same as this. And what is the range of my red function?
0 to positive.
Because it is this.
Is that always true?
That's always true. They're always the opposite.
Okay.
Okay? Okay? So if you can find the domain and range of the original function, because it might be easier for you to see that, then you just flip it for your inverse. Okay? Yeah, that's where we stopped.
Thank God. Good Lord.